Hi, this is Jan 2015 IL. Okay, this is from Jan 2015 IL. So they said it's about a basketball game. Um, a goal is scored when ball passes through rings of the top of the net. You all know that. On the diagram below, draw a path of the ball. Okay, so now this is the typical diagram of projectile you guys are supposed to draw. Something like this. Okay, it should be proper. Let me say, I think mine is not proper. If I think like this, most probably like this. Okay, so this one is done. Now let's talk about, they have given us some information over here. Student given following information if they want to score a goal. Okay, initial velocity of ball is 4.5. Okay, so it was thrown at 4.5, okay, meter per second, 4.5 meter per second. And horizontal velocity is going to be, horizontal velocity is going to be 4.5, yes, 4.5 cos 60 degree at an angle of 60 degree to the horizontal, so this is 60 degree. Okay, and vertically it's going to be 4.5 sine 60 degree. Okay, now they have given us the horizontal distance the ball has traveled. So remember, whenever horizontal distance given, you have to use this formula. And time and speed is known, speed is known to us, horizontal velocity is known to us. So it's going to be u cos theta into t. Since angle is given, u cos theta. If angle was not given, and if they would have directly given us the horizontal velocity, we would have just used this formula, u h into t. They are pretty much the same. Okay, see here, since the angle is given, it's initial velocity into cos theta, and even the distance is given 1.5. So we can use this formula. We can also, what did they write, show that the time taken to travel the horizontal distance is 0.7 piece of cake, as equals to u cos theta into t. Okay, so that is the formula. How much is s? 1.5 meter. How much is u? 4.5 cos 60. How much is time? We don't know. Okay, so let's do 1.5 divided by 4.5 cos 60. 4.5 cos 60 degree. Okay, is equal to time. So let's calculate that. 1.5 divided by 4.5 cos 60, and we are getting around 0.66 seconds, which is close to 7 seconds. Okay, so here everything is given in two significant figures, so I gave my answer also in two significant figure. So that is close to 0.7 seconds. I think we can write I'm not sure about this, but we can write this, that they both are equal to each other. You know what, don't do it, just write 0.66. Okay, next, calculate the vertical displacement of the ball. Now we know, if horizontally it traveled for 0.66 seconds, vertically also it must have taken 0.66 seconds. Okay, it's traveled 0.66 seconds. Now the ring is around 0.7 meter. If your ball is less than that, goal is not scored. If your ball is too much above than that, the goal is not scored. Okay, there is no score over here. And I don't know whether I'm right to say the word goal or not. It's basketball. Okay, let me say the word scored. There is no score over there. So now 0.70. Okay, height. If it is equal, then yes, they have scored. Oh, they use the word goal. Whether goal is okay, goal then. Um, so we know it traveled around 0.66 meter. Let's say this is just like previous question only what we did. Let's say what is the, okay, what is the height it has reached in that 0.66 seconds? What is the vertical height it has reached? Question mark. What was the initial velocity of this? Initial velocity is 4.5 sine 60. It's going up, right? So I want to find at what height did it reach in that time, 0.66 seconds. So what was the initial velocity? Vertical. Because since we are talking about vertical height, I have to use vertical velocity. How much is that? 4.5 sine 60. Okay. It's going up. So acceleration is minus 9.81. And time is, as we know, 0.66 seconds. Which formula? Again, s equals to ut plus half at square. So the vertical height is ut, that is 4.5 sine 60 into 0.66 minus, I'm saying minus because of this, okay, minus half at square, a t square, t is 0.66 square. So let's see how much is that. Okay, do not enter this in calculator directly, do it manually, step by step. 4.5 into sine 60, which is that, into sine 60 into 0.66, that's 2.572, 2.572 minus 0.5 into 9.81 into 0.66 square, that is 2.1366. Okay, so 2.572 minus 2.1366, I'm getting around 0.43 meter. You see 0.43 meter is very much less than 0.7 meter, so no score. Okay, no score, vertical displacement, and we have to write whether. Okay, let us see the mark scheme, whether it has scored or not. What is the question number? Question number is around 50. Okay, it's for 15 only. 15. Okay, let's see what is the mark scheme says. Question number 15 it is. 12, 13, 14, 15. Yeah, okay, correct trajectory. 0.67. Okay, I got 0.66, whatever. So it should be around 0.41 to 0.42 meter. We got 0.43. I think my answer is a bit more because of my timing. Most probably that is the reason. But the method is still the same, 0.41 meter. I got 0.43. Maybe I took it too accurate. Whatever. So the goal is not scored. You should just know that. Okay. The goal is not scored. And my answer is just 0.01, which is not considered. They have considered to be correct or not, I don't know, but yeah, it is very close to the actual answer. It just maybe instead of 0, this is supposed to be 0.67, I wrote it 0.66, and that made a difference, and I took too much decimal values over here, so it made it too accurate. It's okay, it's okay. You just should know how to do the method. That's it. Comment no score. Explain how air resistance would have affected the calculation in B1. B1. If there was air resistance, the time travel would have been much more less than what we got over here, and I think there is going to be a deceleration in the horizontal direction, because we are here, we assume that no air resistance, so there is going to be a deceleration in the horizontal direction, so the even the horizontal path it has traveled is going to be less. So what they said, the calculated time would increase. Okay, oh, they're asking what would happen if, okay, okay. So you have to say the ball would be traveling decreasing, or there was going to be a horizontal deceleration. So it should travel more amount of time to cover that distance. Okay, I misunderstood the question. It will take more time to travel that distance. Okay, more than 1.5. It will travel 1.5 meter in more time, because now before the horizontal velocity was constant. That is the assumption we made, because there is no air resistance. But now there is an air resistance. Okay, so it will take more time to travel that distance. Okay,